Hello students, welcome to today's online video lecture session. I am M. Lakshmi, Assistant Professor of Physics at SR and BGNR College, an autonomous institution at Khammam. Today's topic is Introduction to Electromagnetism. Electromagnetism. It is a part of your course during 3rd or 5th semester depending on your CBCS options. Let us begin by discussing mechanics first. Mechanics. It deals with reaction of objects when they are subjected to some kind of forces. Basically, there are 4 types of mechanics. They are classical mechanics, relativity, quantum mechanics, and quantum field theory. Coming to the first type of mechanics, that is classical mechanics, it deals with most of the physical phenomena that are observed in our everyday life, such as the motion of planets around the sun, the system of Earth and the Moon, the gravitational forces between various objects, etc. It is also known as Newtonian mechanics because Sir Isaac Newton contributed majorly to the development of this branch of mechanics. Coming to the second part of mechanics, that is relativity, it deals with objects that are traveling at high velocities comparable to the speed of the light. Albert Einstein developed the subject almost single-handedly. The third branch of mechanics is quantum mechanics. The subject matter of quantum mechanics is the behavior of objects at the microscopic level, such as the atoms, the molecules, and the subatomic particles. Beginning with Max Planck, the subject of quantum mechanics was developed by a number of people including Bohr, Heisenberg, Schrödinger, and so on. And coming to the fourth branch of mechanics, that is quantum field theory, it deals with smaller objects moving at higher velocities. It is also known as relativistic quantum mechanics. It was developed by Dirac, Feynman, and Schwinger. Next, the types of forces. Fundamentally, all known forces in nature can be classified into 4 categories. They are the gravitational force, the electromagnetic force, the strong and the weak nuclear forces. Among these forces, the gravitational force is the weakest force, but it acts over long distances. Coming to the electromagnetic force, it is the force between charged objects. This force can be either attractive force or it can be repulsive force. But as we know that the gravitational force is always an attractive force. And coming to the 2 nuclear forces, namely the strong and the weak nuclear forces, act only within the nucleus of an atom. Among the 2, the strong force is the strongest and the weak force is weaker than the electromagnetic force, but the range of these two forces, that is, the strong force and the weak force, is very small. All other commonly known forces, such as the frictional force that keeps us from slipping, and the viscous forces in liquids, or even the forces between atoms forming chemical bonds, all these are electromagnetic forces only. In the present course, we are mainly going to focus only on the electromagnetic force. Particularly, we are going to study about charges, the forces between these charges, the electric or magnetic fields that these charges create when they are at rest or moving or accelerating, as well as the electric potentials associated with these fields. Through this course, you will be able to calculate the force between charged objects, electric fields, and potentials of either point charges or extended charged objects. This course also will introduce to you the concept of electric currents, which result from moving charges, and classification of materials based on the conductivity of materials. And towards the end of this course, you will also appreciate the magnetic effects of electric current and the origin of magnetism in materials. Additionally, this course will also introduce you to topics such as electromagnetic induction, which will help you to understand how generators and motors work. This is the brief introduction to your course. And coming to the unification of forces, this course will also aid you in realizing how the subjects of electricity and magnetism are intricately connected, and that these two subjects, electricity and magnetism, are not two different topics but two aspects of a single subject called electromagnetism. Finally, with the contribution of Maxwell and his equations, you will understand that even the subject of optics, study of light, it is strongly correlated to the subject of electromagnetism, and it is known as electrodynamics. And next, coming to the units part, International System of Units is commonly used in electromagnetism. Some of the physical parameters that we mostly encounter in electromagnetism are current, charge, electric potential, resistance, energy, power, and so on. The SI unit for current is ampere, which is represented by letter capital A. The SI unit for charge is coulomb. It is represented by letter capital C. 1 coulomb is equivalent to 1 ampere second. The SI unit for electric potential is volt. 1 volt is equivalent to 1 joule per coulomb. Volt is represented by letter capital V. The SI unit for resistance is ohm. It is represented by capital Greek letter omega. 1 omega is equal to 1 volt per ampere. The SI unit for energy, it is well known from mechanics also, it is joule, represented by letter capital J. 1 joule is equivalent to 1 volt ampere second in electricity. And similarly, the SI unit for power is watt, represented by letter capital W. 1 watt is equivalent to 1 volt ampere. Okay. See you in our next video session. Thank you.